Scenario. A tennis ball with a mass of 0.2 kilograms is dropped vertically downwards off a table from a height of 1.5 meters above the floor. The ball bounces off the floor where energy is dissipated and returned to a maximum height of 1.2 meters above the floor. Question. How much energy was dissipated during the collision between the floor and the ball? The answer. The approach is going to require the use of conservation of energy. Here, we're only looking at the gravitational potential energy because you're looking at a height initial and a height final. So, in theory, if it was just using conservation energy, the final gravitational energy should be equal to the initial gravitational energy, written that way. Now, however, there was some energy lost to thermal, which is ET. So we can adjust the equation here. We subtract an ET to represent the dissipating energy. We can substitute in the values mgh. H stands for the final height. mgh naught. H naught represents the initial height. This equation reads, the final gravitational potential energy is equal to the initial gravitational potential energy minus the thermal energy that was dissipated. We can substitute in our values. M was 0.2, gravity was 10, height final was 1.2, height initial, h naught, was 1.5. You should get 2.4 is equal to 3 minus ET. Subtract 3 to both sides. You should get that. Then divide by a negative to both sides. You get ET, which is the energy that was dissipating, it equal to 0.6 joules. This 0.6 joules was energy that was transferred out of the system. That is the reason why the final height is lower. Side note, if the height was higher, that means energy was coming into the system. Okay? But here, the ET was the energy loss. That 0.6 represents the loss of the energy going out of the system. There you go.